Hi and welcome. In this video, I want to show you the Danfoss Controller talks ISOBUS. Danfoss has developed a new product variant of the XL104 controller, which is listed in the AEF database and has been certified as ISOBUS-capable software for reuse in software testing. ISOBUS is a standardized data transmission protocol for agricultural machinery that enables the exchange of data and information between tractors and implements using a universal language. The ISO standard defines which participants, connectors, data formats, and interfaces must be used. ISOBUS is used in modern agriculture to enable farmers to work as efficiently as possible. Various electronic devices, such as sensors and actuators, are used for this purpose. These devices can, for example, determine the optimal application rate of crop protection products depending on the soil conditions beneath the machine. The resulting information should then be stored for later use. ISOBUS was developed to enable all these devices, regardless of manufacturer, to communicate with each other, while keeping the cabling effort within the agricultural machine as low as possible. For this purpose, the Danfoss XL104 controller was expanded with an ISOBUS stack, which enables standardized communication between the tractor and the implement via ISOBUS. The XL104 controller was selected as the first one to start with for ISOBUS communication, but our intention is to propagate this to other controllers in the future. For the PLUS+1 Guide ISOBUS communication, we offer two options. ISOBUS Basic option includes the support for Virtual Terminal, short VT, and the Auxiliary Control, short AUXN. ISOBUS Advanced option includes the same support as Basic option, but the Task Controller elements in addition, short TC. The Virtual Terminal allows the end user to operate various devices, including those across brands and manufacturers, via a single terminal. The VT is a central component of what makes ISOBUS visually appealing. In practice, the VT is initialized through a series of CAN messages sent between the VT and the implement. The VT communicates its specifications to the implement, allowing the implement to send its user interface to the VT for graphical display. Once initialized, the operator can perform various implement control tasks via the virtual terminal. Auxiliary Control, AUXN. This ISOBUS functionality often corresponds to a joystick or similar control, allowing finer control of implement functions. Note that both a new and an old version exist, and they're not cross-platform compatible. Danfoss only supports the new version. Task Controller, TC. The Task Controller is a software application that records and provides operational information and supports planning. It receives operator input via an interface and is used to plan tasks for the device and execute them via control functions. In particular, it enables automated and therefore more precise control of the device, a key factor in precision farming, for example. The Task Controller consists of three subprotocols, which are all supported in the PLUS+1 Guide software package for ISOBUS. Basic. This is used to collect overall data based on the information provided by the device. This facilitates the documentation of the work performed via the user interface, for example, how much product was applied. Section. This enables automatic switching of sections in, for example, a sprayer based on GPS position, thus enabling more precise use of the device's functionality. Geo. This is used for GPS-based task automation, for geo-based seeding control, for example. This is useful when certain areas of a field require individual treatment. An ISOBUS application starts typically on the customer side, where they need to pick a designer tool to create individual user interfaces for ISOBUS control applications. The PLUS+1 Guide software package for ISOBUS supports two different design tools: the ISO Designer from Jetter and the Designer from OSB. Via these tools, you design screens, so-called masks, with inputs and output elements that get shared basically with implements and the other way around, where an implement would typically send data to the display. These elements are objects which then get supported with either message going from the terminal to the implement or commands the other way to basically exchange data. Once the application inside the designer tool is done, their exported output files will be used in a script to generate a CCP code compiled package, which is then to be integrated into a guide application. The CCP file specifies objects from the virtual terminal's user interface. This allows you to use objects from the virtual terminal in your guide application. This includes writing data to a field and triggering an action via a button. The same process will happen for the task control to generate a CCP from the customized TDOP files, the device descriptor object pool, which is a collection of objects that describe the capabilities of an implement to the task controller. To allow a guide application to communicate with virtual terminal, auxiliary implements, and task controller over an ISOBUS network, Danfoss provides an ISOBUS guide interface software package, which includes multiple compiled code package files, CCP. CCP files contain C code that implement functions to be used in an application. 3 of the CCP files are supplied with the software package: CCP ISOBUS application zip file. These files facilitates ISOBUS configuration and monitors the connection status. CCP ISOBUS stack zip file. These files initializes the ISOBUS stack in the application. CCP middleware CAN socket zip file. These files initializes a CAN socket for ISOBUS communication. Depending on the ISOBUS options basic and advanced, the CCP ISOBUS interface must be generated manually by the user for VT-AUXN and TC client. The VT-AUXN interface defines objects and other specifications of the virtual terminal and will be generated using the mask designer, IOP files, and the provided script. The TC client defines objects and other specifications of the task controller and will be generated using the customized TDOP file and the provided script. After running the script and adding the CCPs into the guide application, all functions, methods, and objects will be available in the graphical code area. Like it is shown here for the step-by-step instruction. First, create and build screens via Mask Designer. Second, once the application inside the Designer tool is done, generate object pool and interface via script to generate a CCP. Third, adding the CCPs into the guide application. And finally, step 4, interact with the interface in guide like it is shown here, where a C code classed instance of message has been created that contains methods that may be called, like the getSoft key activation message. This event would get processed, and an action on the implement can be taken. Or the C code classed instance of command to change numeric value function using the object ID and do value input of the command method change numeric value, for example. How to configure the PLUS+1 guide software package for ISOBUS in guide following these 4 steps will be introduced more in detail in the video number 136. This video gives an overview of the software package content, the minimum requirements and configuration instructions of the basic and advanced options to allow a PLUS+1 guide application to communicate over an ISOBUS network. We hope that you found this video useful. Remember that PLUS+1 community help is available on the PLUS+1 user forum. Check out other videos on our YouTube channel or contact the PLUS+1 help desk. Thank you for your attention.